Hello, everyone. We are all welcome to the sixth class out of 16 classes for the free course on data analytics and introduction to SQL and Python. So I'm going to share my screen now, and then we'll go in straight for the course for today. We are going to be talking on databases and also be um, going into the demo part of installing SQL. Okay, so um, for this course, we are going to look at databases and data sets in analytics, how they relate, right? Then we're also going to examine various databases platforms. That's very important for knowledge sake. Then we would then look at the steps for installing the database platform for this course, which is Microsoft SQL. And we would close by importing a data set into our own SQL platform as well. Okay, so let's go in straight into the course content. So in our previous classes, we've talked about databases, saying that databases help in accumulating or storing data. Since data is not collected one-off or collected at a point in time, data is usually gathered over a period of time. So there has to be a container for gathering this data. And what is used for accomplishing that is known as databases. So databases are used by individuals, by organizations, or even by tools as well to accumulate data. Right. So a simplest form of database is your contacts list on your mobile phone. A database is just a collection of data. So your contact list on your mobile phone is a collection of various contacts on your phone, various contact information on the phone. So databases are databases. Sorry. Okay, so having knowledge of these databases and how they work, right, and how you use them within data analytics process is very, very important. And remember, your data is like the main, the main is like the most needed aspect of your data analytics process, because without the data, there's really nothing for the model to work on. So you also need to understand how to get to where the data is, how to get the data ready, and how to prepare the data ready for your model. So that's the essence for the knowledge for databases. So databases make data collection easier, makes accessibility and manipulation of the data as well to be easier. And database can be in the cloud, it can also be on premise, it can be in devices, it can be in mobile devices, it can be in different in different forms, right? So we are going to look at those different forms. So in my talk, I've told you that there are different forms of databases. So these different forms of databases comes in different variants, and examples of such variants are listed on your screen. You can have databases in large databases softwares implemented as distributed or centralized databases. Distributed databases simply means that there are chunks of these databases in different locations. But in centralized databases, you have all your database in the same location. It could be in form of a software in the same software, or it could also be in form of the devices housing the software. So if you have your database within a computer machine, usually maybe a server computer machine, and that server is sitting in just one location, be it in the cloud or be it within a office or enterprise organization, then you can say that is a centralized database. But if you have an implementation of, let's say you have various branches of an office, and these branches of offices house their databases within their offices, right? Then the data collection for this kind of implementation, you could say, is distributed, right? But let's say there's a central office location, and all the offices are just connecting to the database in a central place using network connections, then you could say that's centralized. So that's just, you could see different variants of centralized and distributed databases implemented in many organizations, right? We could also have the different kind of network for databases. It could be in a flat file database structure, right? So flat file are usually sitting within desktop or within individual computers, right? Then you could also have the hierarchical type of database, right? So in hierarchical type of database, there's some form of hierarchy within the structure of the database. So certain data levels are available to certain users based on their roles and yeah, based on roles and security. So you also find this kind of implementation in various organizations, maybe depending on the kind of data they want their staff to be exposed to, or maybe depending on the kind of implementation within the software that will be using this data. Then you also have the network kind of database. So in network kind of database, everyone could have access to different types of data depending on the network flow. So you have this kind of implementation for workflow diagrams or for workflow kind of work processes in organizations. So based on your unit or department, you could have access to other data in some other units or department that are not related to you, or even in some other kind of departments that are related to you. So it's just different workflow for different forms of data users within that organization. So these are different variants of databases, and various implementations are used in these various regards. You could also have the document, file, or graph kind of databases. So the document file database, just like the name suggests, deals with having databases that it could be a form of distributed or centralized form of database, but it involves some kind of file data, circulation, right? Then you could have the graph type of databases as well that involves maybe data on some form of implementation with its structure looking like a graph form, right? Then you have the major variants I want us to concentrate on for this topic is the relational and the non-relational kind of databases. So in the relational kind of database, you have your usual tables and you have your usual tables and data variables within them, right? And within this usual um, variables, we have some form of structure within the database. Um, Notwithstanding, the previous databases I mentioned could be it could be implemented as a relational or non-relational database. But the kind of variance we're looking at in them is not might not be structured. It might just be okay, where the data is located, or how do we intend to access the data, or the kind of data we intend to access, right? But in relational and non-relational, they're looking basically at the structure within the database. So in the non-relational database structure, we have databases, not having a clear relation within them, but it's just in some form of no relation, a form of flat file, wide form of data storage, and you can extract all the information about a subject, right, by accessing the data. So those are different variants of databases, and databases clustered form what we call a data warehouse. So a collection of database form what we call a data warehouse. So the data warehouse, in some kind of truth, looks like a centralized database that forms a one version of truth for an organization. So meaning that everybody, right, irrespective of their role or their level, is connecting to the same data source. So if there's any change, that would be on the same centralized database environment. Data warehouse is mostly needed when creating analytics, right? Because in analytics, you need to collect all your data, ensure that there's just one form of truth for all your data, then prepare the data before applying your model or algorithm to learning the abstractions within the data. So data warehouse implementation within the data analytics process would help you create your transactional data warehouse, and then you also have your analytic data warehouse where the modeling actually takes place, right? So the data warehouse concept simplifies the reporting and analytics process of the organization, right? So as a data analytics expert, what you would always request to work with would be the data warehouse of the client organization, because that's where you should have your collection of all the data and a single source of truth. Right, so on the data warehouse, your data warehouse is just your database. You also need you need a database management system, which is our focus for the use of things like Microsoft SQL or the variants of the SQL, right, for managing data. So your data, is just stored in a container, right? But for managing the data, you need your data management system. Your data management system can be compared to what your Excel software is used to do on data, right? So the Excel software itself is a platform, right? So your data management system is a platform, right? Your Excel software contains collections of sheets that are like your tables, right? So your data warehouse actually contains databases that can have um, tables, right, within them. So there's much more capacity within a data management system than what an Excel tool can have, right? And that's why Excel is limited, because Excel is just a single file. So Excel being a single file can be compared to just one database um, um, application, or just one database storage, right, that contains many tables. But a database management system can contain several databases, right? And of course, your databases contains tables, right? Your Excel contains sheets, right? Your tables contain rows and columns. Your Excel sheets as well can contain rows or records of several data, and you can label them with filled columns, which are your columns. So you can see the similarities and dissimilarities between your database management system and your basic tool, which is Excel, right? Um, so in most cases, as a data analytics, what the environment you will be faced with, wherein your data will be accessible, would likely be in a database management system, right? So, and database management system can come in two variants. It could be SQL based, and it could be no SQL based. The SQL based is the relational type of database management system, which has some form of structure within it, right? So the non-relational NoSQL based comes in a wide format that has very minimal or no structure in it. But the basic principle in a NoSQL based non-relational database management system is that it uses the concept of key and pair. So just one key or just one field is identified as the key to unlocking the rest of the variables. A quick and common example of a key would be like your serial number. So every record, and your key, of course, has to always be unique. So every record within a table is uniquely accessed by a key, like the serial number. So the record number 18 is having the key of 18, and every other thing within it is a pair for your key. So a flat file structure would, in many cases, have a very wide table format. Wide table format meaning that it has many columns of data, right? And then there's a form of key that is used to identify that record. So this implementation is used when you want to have minimal structure within that database for certain reasons of um, accessing that database much more easily than using a structured database. What is actually most common is the structured form of database, because it makes data storage easier. It also makes data retrieval faster. Data retrieval in a NoSQL based system might be much slower, because it's a wide table format. So you the process would likely take longer to be able to do some filtering or some retrieving from that form of data. So the main difference is just that the NoSQL actually uses the key value pair kind of structure, which is a minimal structure. But in a SQL base, you have relations um, amongst different standardized tables within the database. Okay, so many people usually ask that, why do we use database management system? Why don't we use Excel? Um, why don't we do analysis with Excel and all that? From my own perspective, if you're not, if you are dealing with uh, relatively small data, I would say relatively because um, the word big and small is actually relative. If you remember our talk on big data, if you are using data can be that is relatively small in handling, then Excel is good enough, right? Because Excel does some interesting analysis. Excel is also having a lot of plug-in, add-in into softwares that can do some um, analytics and modeling for you. So if it's relatively small, I would just advise that you do or start off with Excel. But if you are dealing with big data, efficiency and productivity is better with a database management system. And preferably, in most cases, you would be using a relational database management system, which has structure within it. For instance, when we're talking of relational database management system, we're looking at a database management system that has different tables containing different subjects of information. Like you have your customer information, you have sales information, customer sales information, you have customer, you have sales region information, you have different subjects, but these different subjects all relate to a concept. So when you are saying relational, it means there's a relation between all these different subjects within that database, right, for which you have gathered the data, right? And so you would most times find um, data accumulation in many organizations implemented as a relational or structured, or we can call it formal way of accumulating this data, which is usually based on a database management system, right? So these are the various differences for which people consider using Excel or using SQL that are written on their screen. And SQL um, is far better than Excel in the sense that Excel would only usually allow you to understand structure between two variables at a time. If you remember our demo on Excel, we did something on data sets tables, and that could only be done on two relations. You can see correlation between two variables max at a time in Excel, but in SQL, you can do much more relational dimensions, right? You can see much more um, interesting information about your data. So database management system is actually much more robust and much more defined than using Excel. SQL database management system also allows multiple users to access data, but in Excel is just a file, so it's just one user, right, at a time. Though we have Google Sheets now that is cloud-based, um, available to individuals through their Google account, right? You can allow multiple users to access Google Sheets, but changes to the data is not as synchronous as you have changes to data in SQL. So um, most times, what runs at the background of many mobile tools or many software tools or many tools that uses AI or machine learning or even automation, right, is a database management system. Okay, so in using or accessing a database management system, you should be familiar with what we call SQL. Right, we mentioned in our previous slide that a relational database management system is SQL based. It simply means that you can access or manipulate the data within a relational database using what we call SQL. SQL simply stands for Structured Query Language. This is a standard, I'll call it, way of communicating with data. Communicating in the sense that when you write this instruction in text, right, on a database management system, it would help, the database management system will interpret it to performing some actions on your data. So in the broad sense, we call it language because language is used for, communicating. So in exchanging knowledge between two entities, in this case, as humans, in exchanging knowledge between, just like we're trying to exchange knowledge now, I have to communicate to you in a language that you understand. So the same way with the concept of data, data is sitting somewhere. So for that entity that is housing the data to communicate with another entity that wants to access the data, the link for communication between them is known as SQL, right? So in my own terms, I say that SQL is a language that must be spoken frequently by data analytics, right, to help them to gain access and be able to manipulate their data, right? So SQL has actually become a standard for communicating with data across many database management implementations. So scientists all over the world agreed to SQL as a standard. You can see at different times when this was agreed to, and SQL has been as old as these various times. Just after big data started becoming more prominent and people started accumulating more and more data. So SQL was developed as a scripting or text way of communicating with data. So if you look at various database management systems, the SQL variance between them is about the same, right? As we go on in this course, we're going to write some SQL scripts and you are going to see how systematically this script is developed. I'm sure by the time you write some scripts and all that, you will get familiar with SQL scripts and you can use that to manipulate your data, right? So having said all this, database, and we have several examples of SQL, of SQL management system. That's a relational database management system. We have Microsoft SQL as an example. That's about the most common example because Microsoft products easily interrelate with many organizations. So many organizations have Microsoft products standards, implemented. So Microsoft being a much more popular and common implementation also ships along with it Microsoft SQL, right? So we'll be learning Microsoft SQL in this course, but we also have some other database management systems. We have Oracle DBMS, database management system. We have MySQL, and we have those three popular ones. We have some other ones too, but might not be so popular. We also have SQL implemented in Hadoop. Hadoop actually has both SQL and no SQL implemented in it. Right, so those are examples. And There's a free edition for SQL, Microsoft SQL, that is available for everyone to download free of charge, no license, no, it's free, and free, it's free throughout the lifetime, right? And the edition is called Express Edition. So we are going to be downloading that today. I'm just going to show you the link to downloading it so you can download as well. And the SQL software, the database software actually comes as it comes with a command prompt for writing your SQL script, right? So you can write your SQL script on that command prompt, but the user interface on that command prompt is not friendly as such as when you use an integrated tool like the management studio. So for for um, for many users, you it would be good to implement both the SQL Server software and then the management studio tool that ships differently from the software, right? So the management studio actually um, helps you to access your SQL software from a friendly interface. So we are going to implement that as well, and then you see the clear difference and also see how to implement your DBMS management system on your personal machine. So with all said and done, it is time to try out the implementation. I'm just going to run through the steps and then I'll leave you to try the implementation on your own. If you have any challenges installing the software on your machine, you can send me a message either by email or by putting a message in a message box area, and I will sure respond to you. So the step one to implementing SQL is to installing, sorry, I keep using the word implementing. To installing SQL is to install the SQL Server software first, right? And to install SQL Server software, you can do a simple search on Google installation of SQL Server free edition, right? And once you do that search, it will pop up within its results, Microsoft SQL Server downloads, or you can simply copy this link on the screen, which is showing the link to where you can find your SQL software tools. So once you have this link on, it will show you a page that looks like what I have on my screen here. So you can choose your software type for installation, either Windows or Linux, or Docker, which is usually in the network server related machines, right? So you can choose either of these and download. So you can also try this along with me, right? On your computer, just log on to Google, click on um, your log on to Google or your preferred Internet Explorer, put in the link to take you to this page, then download the software, right? So after downloading the software, we're also going to download the user-friendly interface, which is the Management Studio tool for accessing our software. So you'll find that as well on the same page. Just scroll down a little bit, you find Download SQL Server Management Studio, SSMS. So download these two. They are not very heavy, they are quite light, right? So after downloading, you would install the SQL Server software first. Please ensure to install the SQL Server software first, right? there are certain requirements for this installation, but if you are using if you are using Windows 10 OS and above, which is usually the case now, you would likely not have any challenges, except maybe you have a previous instance of SQL Server running on your machine for now. But of course, if you're having any challenges, you can drop me an email or you drop me a note and I will respond to you. So just follow the prompts to install, and after installation of both, and our next demo will be on how to import data from Excel into SQL. So the demo for that is to simply locate SQL Server 2019 import and export on your menu page, click on it. Once you click on it, you follow the wizard prompt to importing your Excel into your SQL. So thank you for listening. I look forward to hearing from you. Bye.